Hello everyone. As usual, let's wait for 2 minutes until everyone joins us. Okay, I think we can start. Yeah, welcome everyone. And today I'm yeah, today we are going to discuss, basically, I want to start with just showing the final solution for the example we discussed at the end of our previous session. I think I have written all the necessary details here, and yeah, push the code in Bitbucket. So I think with this explanation I mentioned here, that should be clear for you. It's just don't worry, this is just a brain training example. So just for a little bit training. And yeah, I hope I described it. I described all the details. And if you still just want to explore this one and you still don't understand something, please ask me. But yeah, it's just if you want to explore this example as some additional brain exercise. Yeah, otherwise we can move on with the regular expressions. Just not move on. We'll finish with regular expressions we discussed last time. So yeah, the first one was the lucky number, where we just had to replace all the non-integers and then take the substring of this one, and at the end we need to check if the sum is 25. Then we want to return true, otherwise yeah, return false. Okay, seems that the Eclipse needs, yeah, okay. And yeah, as we can see here, just small reminder, if we have the return statement, it means that the execution of the program will be finished. So if we call it from here, it means that we won't go next. Otherwise, we go next. So that's why there's no else statement, because that would be absolutely the same. Yeah. Hope you understand it. Okay, and yeah, that was pretty it for lucky number. And let's move on with with that famous but the task some of you asked me about. So yeah, here we need to find if the text matches the pattern of Kenny or Kelly, and as it says here, it can be written with arbitrary number of n, s or else, starting with 2. So it means that we first of all we need to have the pattern. Let's define it this way. And here's the pattern. So we start with KE. Then we need to provide the letters. We want to check. Then we pass how many letters should be there, and we finish with Y. Then we use the pattern class to actually generate the pattern, to compile the pattern. So here we use the method compile, and we use the compile method here. And then we use the matcher class which will uh, which will process the input for this method, and so then we want to find the pattern. So here we have the pattern. We get the matcher from the pattern based on the input. Then we can process if the matcher finds the pattern provided here in the string. For this purpose we call method find, and then we just need to return the start position. Yeah. Start position, otherwise return -1, yeah. Just as it was stated here. And the last one is about the phone number. As stated here, we can start, the phone can start with 67 or 66, and it must have the prefix of, but not obligate prefix of 371. So it means that we need to again define the pattern of this expression. So here we create the regular expression, then we provide the number 371, I think. 371, which is not mandatory. And then we have the choice between 67 and 66 as mentioned here. Then we can add the alphabet, let's call it alphabet, of the symbols we can use. So we can use for digits only and 6 at the end. No, not 6, but 6 number, 6 digits should be after that. Then again we use yeah. Then I think we can simply return yeah, we have the alpha number here. So that's the string, and directly from the string we can use method matches, which will validate us the number. Okay, let's check. Maybe I missed some symbols here. Okay, I think I missed something. Okay, here we need to add the comma. Let's check. Yeah, for this one, yeah, we had to add the comma here, which basically means that okay, maybe not in this case. And here we need plus near index 1. Yeah. And so since plus that's the we need escape character, yeah. Escape character, and I think that's practically it. Yeah, okay, so now everything is fine. For the regular expressions. Okay, that's it about X206, and we can move on with, as I promised you, I will do some explanations about the annotations, which are widely used in Java. So let's start. I'll create a new package. Okay. And then, yeah, let's have a simple example here. So as usually, yeah, just a simple example. You already used it. You already used it for many times. Like imagine we have a base class, then we have the method. That's will be protected method. Then you have a subclass which extends the base class, and you want to override this test method. So as you can see here, we have annotation which points us that this particular method is overridden. Yeah, and so if we remove it, that should be fine as well. Okay, let's simply have main void. So that the program should be compiled, and there should not be not any issues with this one. So basically we can escape writing this annotation. In this case, we can already see it. For example, in Eclipse we have this symbol, which means that this method is overridden, but by default it goes in the way that the method is overridden. Right? Yeah, which basically points us, if we simply read the code, like, okay, in Java we have this one, but maybe if you read the code from somewhere else, it's pretty useful if you directly can see that this particular method is overridden, but this annotation actually do not have any impact on the behavior of the program. And yeah, that's why it is not mandatory, but it can have the impact on the documentation. As you remember, we can have the Java docs, which will basically add the explanation for this annotation if it's written. So basically, if you have the annotation, the Java docs will be created in different way with more detailization about the actual code. That's one thing, and another thing is that, as I mentioned, the annotations do not impact the behavior on of the program, but they must be used correctly. So you cannot just like here, if we create a new method, void test2, method, for example, just something like this, and you want to point that this method is also overridden, you can see that it shows the error, and it basically says, of course, if we, for example, if we want to create this class, if we want to create this class, I think that should, okay, not, it doesn't show in this case, but if, okay, maybe if we call it from here, maybe let's just declare it public. So that, yeah, as you can see that it shows the unresolved compilation program. So it means that the program cannot be compiled because we used a predefined annotation in the place where the method is defined as new method and it is not overridden. And yeah, if we point to, if we tap the cursor on the annotation, we can see that it shows that there's the target, which means yeah, you can see here under the Java link override, and there are two annotations mentioned, and the first one is target with the value method, which means that this particular annotation can be applied to the methods, right? So you cannot place it in other places, like you cannot use it here or here or somewhere else. Yeah, it actually shows that this annotation is used in incorrect place. So next to the, so again, if we go here, we can see that it must be here. It shows that it must be stored, not stored, but used before the method. Yeah, and here retention, it's not really important for, not really interesting for us, but it basically shows the time when, not the time, but the maybe the lifetime, let's call it the lifetime, where this expression, not expression but annotation will be shown. So it means that it is checked on the source, so we can already see in the compiler that we have the error. But in this place it actually doesn't show us the same error as if we use here, because basically we place it in the correct position, but not in the correct case. Right, so we need to remove it, and after that we won't have the problems. And then you can see there are different type of the annotations. Maybe we can define our own annotations. Maybe let's do it just simply discuss the syntax and some main features. C, this one Java link. So this thing is predefined, so there are no external libraries used for it. But what we can actually import some enums, some constants, some classes to be used. So here we have enum of the element type, which actually shows us, as you already seen here, we have the the method which is the type use of the element type, and we also need to import the target to show the actual place to which this can be used. So okay, maybe if we go to the target, we can see that it is defined as the public interface. So basically the annotations are considered as the interfaces. Maybe if we go to any annotation, predict in generic, let's call maybe about the terms. If I call something generic, it means that it comes from the some not custom uh, libraries. Yeah. So in this case, I consider these annotations as generic one, and we can see that these are defined as the interface, but not the simple interface we use for the classes, but interface this way. Okay, let's move on. So we define the type, and now we can define our own annotation. So basically, we use target. Before we define the annotation, we can use the target. Then we can provide the element to the target, which actually shows us the type for the element this particular annotation can be used. So as usual, we can have the method, module, package, field, parameter, and so on and so on. Maybe let's just, for example, use parameter, and yes, no, we don't need the semicolon here, because below this one we need to declare the interface. So for this location. Okay, and then let's define the interface. Then the interface can be just simple param test. Okay, and now we don't have the errors. So basically we have the target, then below the target we have the interface of this particular annotation. So if we have the target, we should also have the interface of the annotation to be used. And again, we cannot use our annotation somewhere here. So the name of annotation is this one, parent test. Parent test. We cannot use it here because we defined that it must be next to the parameter. So if we let's check if it should be. Okay, yeah, it should be here. Should be before the parameter declaration. I think it cannot be used here. Yeah, we should, because that would not make sense if we just place it at the middle. So it should be used before the parameter is declared. So that's basically the way we can use it. And for here we just point to some parameters that maybe like just if we want to add some uh, some specific characteristics, like maybe not in this case, I just use it as testing. But if we just want to point to some specific elements, like if these elements are kind of specific with some specific features or maybe history or something like that, then you can point to them using the annotations. Like for example, if we declare again the target one, then we declare again let's use the element type to which we want to use. I want to use for the method, for example. Then I declare the interface, and for example I want to point that just which methods are used for the testing purpose. And like in this case we have these two methods, so we can point to them that they are used for the testing purpose. Yeah, and we should not have any compilation errors here. Yeah. Right, so basically, and of course, yeah, we can have multiple annotations as well if needed. So basically we just want to point to something. Yeah. What else can we have? Can have some repeating annotations as well. Maybe let's just explain for the example. So we need to import annotations as well. Maybe let's just write a code, then the imports will be imported automatically. Yeah, here we can add the retention as okay, I think we need to, that won't be imported automatically. For retention, then we need to import repeatable. Then what else do I need? I will need retention policy that would be used to point to which particular at what time this will be shown. This will be used, but yeah. Okay, so here we can use retention where we point to our retention policy. So basically here is the description. If we use it if we use the class, then it basically shows us where this will be checked. So for the class, annotations are to be recorded in the class file by the compiler, but need to be retained by the virtual machine at runtime. So this is the default behavior. During the runtime, they will be retained by the virtual machine at runtime. So they may be read reflectively, and source they will just be discarded by compiler. So maybe let's use source, and then we can use we can define a repeatable annotation. So maybe so here we can point that this is repeatable. And here we define here we maybe let's first we define the okay, maybe no, we need to define here. Okay, let's test tree repeated annotations. And then again we can define the interface. Then we can have the interface of words, and you'll see how this can be used after that. And here we can have the word. So basically the idea is that we will be able to put some let's just test. Put some parameters inside the annotation. In this case we define that we'll have two parameters inside. The first parameter is word, and then we can have the value, and we also use the default one. And then again let's use the retention. Use the source, and here we need to define our annotation, and which will just be the array of the values, not of the values of the word, the words. Value, and we need to use the value to actually get the value. Okay, to have the values. And that's practically it for the definition, and after that we can use it. So in this case I didn't mention to which element this particular annotation will be used, so I can declare it everywhere. Like for example here, if I use the words, so I use this annotation, then I simply put so as you can see, here we have the word and here we have the value. So I put two parameters, the value here. So here we have the integer. In theory, if we don't put it, that will use the default one. And if we don't put everything, that will also use the default one for both of them. Okay, maybe let's just simply leave it here. Then maybe let's use it here. second. And here we provide value. Okay, and we can also access them. We can access to the array of this of these annotations mentioned. Yeah, we don't. Yeah, for annotations we don't need the square brackets and the semicolon to be used. Okay, and okay, for main method we can, for example, print just a moment. Oh yeah, we also can use one additional import which will allow us to retrieve the parameters dynamically. So to use it we need to, so we have the class method. So yeah, the method is the class. Then this way, and we need to use the try catch here. Try. So I'll explain you why do we use it. And why do we use try catch here? Such method exception. Stack trace. And so we can dynamically okay, maybe can dynamically get the class. Okay, maybe what we can, in this case we can just simply order, yeah, we can simply maybe X this way, simple test, then get class, and from here we can get the method. Get the method, yeah, just with one parameter. And then we can print out the annotations used in this method by just getting test repeat annotations this class. And yeah, one more thing, we need to get this annotation from the method. So we use method, then we ask it to get annotation. So this will call this class, and so, and I think that's okay. So something. Oh yeah, sorry, I just missed that we have the method main here. Such method exception. Okay. here we have the class defined, which is correct. Then we create the object, which is correct. Then we get the main method from this class, which should also be correct. But for some reasons it shows that there is no such method found here. Okay, that's it. But yeah, so if it should be defined here. So here you define the interface, then you define it as a class. This way. So this must likely the place. But in this particular case, the error is that it shows that this this method is not found, or we have a simple test class, which is this one. When it comes anyway, yeah, basically here I just want to show how we can have multiple annotations, and basically how can we display the list of these annotations in the end. In the real scenario, again, as I said, you can have multiple markers in different places about in the code. So in theory, you can have many. You can have many. Okay, maybe let's don't use the method, just to not overcomplicate. So let's just use the class here. So yeah, from the method or from the class you can ask to get the annotations, and if these particular annotations are found. So so okay, oh yeah, so that one, that's okay. So don't need to have this try catch here. So basically, okay, maybe okay, that's already used string. Okay, never mind. I think maybe basically the idea is that we can have multiple annotations, then we can maybe let's have a break, and after the break I will solve this little complication here. yeah, I just found some mistakes. First of all, we need to use it during the runtime, because in this case we'll check it during the runtime. And yeah, since I just want to use the class, so I simply use the class as the type, and then I retrieve the annotation. So as you can see, we have two annotations, and next to the class, and if I run it, I just simply see the list of all the annotations used, and as we can see here, this is okay, yeah, that returns us the type, and maybe let's check what the type for this one is. Const string. Okay, that's the generic, maybe let's not touch it. Yeah, so basically the idea is that we can, sorry, not here, and that would be a little bit complicated to parse it to the array, but we can actually see that we can display all the annotations used in this particular, before this particular class. If we add the additional annotation inside the method, that won't work, because we just here we just pointed that we want to get the annotations from the class only. If we here, yeah, from the class only. If we want to, like, we have the method main. Yeah, from the method we cannot get it. In this case, as I shown, we need to load it separately. Maybe that would be a little bit overcomplicated for us, but in this case we just see that we can get the list of annotation used in this class, which basically can be used if you have long code and you want to get the list of annotations, you can use it. And also the idea is that we can use basically the main idea of this example was to show that we can add some parameters inside the annotations to maybe to add some more description to them. What about some popular annotations? We can think, not sure if you faced this already, there's such annotation like deprecated, and once it is applied, we can see that to all the places where this method is used, it shows us that this method is deprecated, and it is not suggested to use it. However, we don't have the compilation error here, but yeah, we can see that it shows us that this method is deprecated. What can we do here? For example, For example, here we can use annotation suppress warnings, and we need to provide the parameters to this. Yeah, to this annotation, which can be done this way. We need to pass the array, and here, for example, can pass that it is checked. Sorry, yeah, this one. So we have two parameters here. Maybe let's go inside and check what are the. Oh yeah, there's the array of strings which can be passed. So we pass the parameters, and yeah, we don't need the semicolon as usually. Yes. So, okay, maybe in this case it's already declared as deprecated. What we can do here, if we maybe let's comment out because we don't really use it now. So we have the method test void from the base class, and the same from the subclass defined as deprecated. So we can try to call it. And okay. Test method. And by default, so what's the question? Multiple annotation just means that we can have basically the list of repeated annotation. Like in this case, you can see that we have in the result we'll have the array of annotations here. So we have one and the first and the second annotation, and then the result. This will be used as the repeated annotation. So we can simply use the same annotation twice here. Right. We can use it twice with the parameters. That's the idea of the repeat. That's why it is repeated. It is called as the repeated one. So okay, let's use it as the public one, so it makes more sense. Let's just create a new object. Base class. And as we can see, it also shows us that this method is deprecated. But if we use the suppress warning here, okay, that's sorry, that needs to be used here. Yeah, needs to be used here, and okay, we can can add some parameters inside. So in this case, it should not. That's a little bit strange because okay, we have a method test method, which is defined as the deprecated. Yeah, here. Okay, in theory, this should remove this compilation error. I'm not really sure why it does. Okay, maybe let's. Not really sure why it is still here, because normally that. Okay, but if we remove it, okay, I should not have the. And that's a little bit strange, because that should remove us this warning, but it's still. But it is still here. Checked. Okay, yeah, okay. So if we was then. Okay, that's a little bit strange because that should remove the warning that that's deprecated. But for some reasons it does not remove. Okay, maybe I will check it after that. But in theory, that should work in the way that this will remove us the warning for the test method. Okay, I will check it maybe a little bit later, but basically I hope you got the idea that we just, if we use suppress warnings, that should remove the warning that we have here. Okay, maybe let's not stick with this one. I think that's pretty it about the annotations. Basically, yeah, they're not used for the behavior of the code, just for some compilation and documentation purposes. Okay, let's go to the lists, to the collections, to the presentation of the collections. So yeah, and let's start with the collection interface. So basically, yeah, the collection is used to store the items, multiple items with the same time, with the same type as one unit, as a single unit. And please note that collections, the elements must be the object. So let's create the package for the collections. Just in the first test class. So the collection, that's the interface. That's the interface. In Java, yeah, that's interface, which needs to have the type. type inside, and we basically use there's the yeah, and we basically use the several classes, several interfaces which actually not implements, but use which use the collection interface. So basically, yeah, there are three, and three of them set, list, and queue, but we already used list interface many times, and as you remember, we can declare the list, and what we can do, for example, the list of integers, yeah. So simply declare the list of, and yeah, we need to import this class as well, and we can store the objects only, so we cannot store simple primitive type, we cannot store like char, for example. We need to store the proper class, not from char, but I think there was yeah, character, sorry. So instead of char as primitive type, we need to use character class. Same for integer, it's already shown for float, and for double. So we must have the object type to be defined. Yes, in theory we cannot escape. We need to provide the type. But also in general we can define it as the object. So basically, in this case, we can actually store every object. Like maybe let's have a small example. As usual, we use the array list. Yeah, we usually use the array list. We'll talk about the different type of lists a little bit later, but actually, if we use the object, in this case, we can basically add the numbers. We can add the strings. We can add the strings. And we can add some different classes inside objects. So that's also fine. So as it states here, it's not yeah, that's correct that it can store multiple elements. The only difference is that basically we can have the elements of the different type. Like if we define the list as the object, so we can basically have any objects inside. If we define with some specification, like we need to store only integers inside, then we cannot actually add string or something else. Yeah. So we provide the type of the list to be used. And okay, full screen. And there are most prominent sub-interfaces of the collection. Yeah, as we already seen lots of times. List, which is the ordered collection. So we have the sequence. we have the sequence of the element, we have the first, the second, the third element, and so on and so on, which is basically stored in the collection. We can go through it, we can access all the elements, we can change them, we can clear the list of the elements, and so on and so on. Also, there are different types of basically of the simple list. We usually use the array list, but there's also the vector. I think you know what the vector means from the mathematics. It's just that's also the sequence of the elements. Just here the only difference is that that's thread safe, since we will not talk about the threads, so maybe let's skip it. But yeah, I think you already heard this term thread safe. Maybe a very short explanation about the threads. Like, imagine if we have the instance of one object created, then if and we have that one application, some application which accesses this particular object, then we have one user which uses this the application where this object is used. And basically the idea is, for if we have multiple threads, like there's one user, there's another user, the idea is that if it's thread safe, it means that if one user, in this case what's in one element, in this case one user, access this one, it means this particular object, it means that from another thread this particular object cannot be accessed. But yeah, that's a very short explanation. So basically the thread safe idea is, if we have multiple threads, then thread safe means that if the object, in this case the list, is used and from one thread, that won't be touched from another thread. It's not really important for us at the moment, but if you go deeper with the stuff, then please note that if we have, so the array list is not thread safe, but if we have the vector is thread safe. But the vectors have all the same things. There are some difference about the way this is structured, but we'll not go deep with the differences between the vector and the array list. There are some difference in the construction of these two types of lists. Yeah, that's about the lists. Then we have the set, which is I think which is the closest type of the collection to the tables. Like as I said to you, as explained to you on Saturday, if we can consider collections in some way as the tables, and that's yes, that's really good question. So, but maybe I think there was the table of differences between them. Yeah, just one moment. I will show you the table which shows the difference between the array list and so yeah, there are five main differences between them. which is so array list is not synchronized, vector is synchronized. That's not really important for us, but the second one shows that array list increments 50% of current array size if the number of elements exceeds from its capacity. But the vector increments 100%, which means that it doubles the array size if the total number of elements exceeds the capacity. So it means that from the performance point of view, from the memory point of view, the vector will take more resources. And yeah, the vector is also maybe a little bit older approach. So that's the legacy. It means that it comes from very beginning of Java versions, but the array is used from one introduced in Java Development Kit 1.2. That's not really important for us because at the moment we work with new Java versions, and we don't really care about the legacy code. But that would be important if you actually work with legacy code. So for some cases, array list is not used. But actually, yeah, the idea is that, as I said in the second point, from the memory point of view, which also means from the performance point of view, array list is much faster than the vector. Because vector does the synchronization. Maybe let's not really talk about it now. And yes, that's basically used for the threads. So using the vectors, we achieve that it is thread safe. So again, it means that it cannot be accessed from different threads, but in our particular case, we don't really care about the threads in the examples we are working with. And another point is that we also just we care about the performance. So in this case, we don't really need to use all these features for thread for the safe of the threads. So it basically means that in our case, it's fine if we use array list because it's faster. And yeah, maybe the fifth point is not really important for us. Basically, what I wanted to explain is that we use array list because we don't really care about the threads at the moment, and because it's faster than the vector. So yeah, that's the answer to Sweatman's question, why we use array list, not vector. Right, let's move. Yeah, let's move on. So, and from just a simple code point of view, by the construction list, array list is more simple. It's constructed in a more simple way. That's why we use it. Then we have the set, which, as I said, is maybe yeah, not this one, but yeah, the set. The idea of set is just that it cannot contain duplicate elements. So just a simple example here. The set, let it be the set of integers So then again for the set we cannot construct yeah, we cannot normally construct it, but for the set we also have some specific classes which implement this set. Maybe let's start with the sorted set. Sorted set. Yeah, we need to import it. We need to import. Oh, yeah, that's also interface. Sorry. Yeah, maybe let's use tree set here. Tree set. We'll talk about tree sets a little bit later, but yeah, it's fine. So if we add something 43, then we add 12, then we want to add again 33, then we want to add another value, and let's print it out. Set to string. As we can see, it has on first of all, as we can see from the schema, that's the sorted set. So it does the sorting. It does the sorting, and it cannot have duplicate elements here. So if we try to add another element, it does not add it. Right? So that's the idea of the sets. We'll talk about them in details a little bit later. Then we have the QM. That's a collection used to hold multiple elements prior to processing. Yeah, like if we have the buffer, simple one. Imagine every queue you can imagine. That's basically the same approach. String. Then let's check what are the classes which implement. So we have priority queue and we have linked list. I think that was another queue, but okay, maybe let's use linked list as the queue. Okay, I think that was there was another class used for QA, as I remember. Let's check. One moment. Okay, maybe let's start with priority queue. That would be a little bit more interesting. So yeah, imagine we have the QM, and after that we can add some elements. Add some elements. And yes, okay, let's add one more element to here. And yeah, let's print it out. And as we can see, it places the elements in the way that if we add the element at the end, it goes as the first one. And if we, so it basically goes from bottom to top, yeah, by adding and yeah, so basically it has this interface has some methods like element, which basically shows us which one is the is the next element in queue. Right, so oh yeah, okay, that's okay. A moment, so I think that should be the opposite way. Just a moment. Okay. Yeah, that's okay, and yeah, I think that should go in the opposite way. It's a little bit strange, so we have the method peak as well. Yeah, which also takes the last one. That's a bit strange, because I think normally should take the first one, because if we have the queue, it makes sense if this selects the first one. That's, and of course we can have the iterator. Iterator, which goes process all the elements from the queue, so we can go through all the elements, ask if it has next, then simply print out the next element. And this will go through all the elements, but again, that's a little bit strange for me, why the Giannis is not first, because I think it normally because I think normally we should go from the first to the last. But okay. Okay, maybe let's move on. So what's the error? In our case, that's fine. So what else we can do? We can pull the element from the queue. This will remove the current one who is on the priority. Yeah, and the same way we can also remove the element which will also remove. Yeah, just one moment. So if we use the pull, that removes us the first one who is on queue. If we use the method remove that, sorry. Yeah, that removes us the first one. So basically the idea is that the pull removes the element which is the next one in queue, but the method remove removes the one who is the last in queue. So in this case, okay, that's about the queues. But again, that's a little bit strange for me why it works this way, not in the opposite. Okay, never mind about now. I'll check it why it works this way. Because I think normally it should work in the opposite way. If we add something to queue, so the first one to queue should be actually the head of the queue must be the first element added to the queue, as it usually happens in real life when we have the queue. Also, if we talk about the examples of queues, like if we have the stack, a simple stack of the methods, that's also the queue. Basically, every stack element is the element in queue, which actually waits. So that basically does the queue to finish the program. Yeah, and yeah, that can be used in every place we want to replicate the scenario of queue. Okay, then we have the map, which contains again the elements and the keys. So that's that's this interface map. And yeah, maybe let's use the tree map as well. Just a minute. So we use the map tree map, and as we can see, there are two types of object types to be provided. The first one is K, which stands for key type, and the second one is B, which stands for the value type. Like if we have the simple example of keys as the integers and the values as strings. we can use it this way. So we provide the type of the keys and the type of the values. So if we to add map, yeah, there's no add method, but there's method put, which points us to the, which basically allows us to add the values. So like imagine we have 1, 2, this key, and the value is, okay, let's use the name Yanis for example. Then we can put another 1, 2. For example, then if we want to add the value with the same key, yeah, maybe let's just simply first of all print out the current one, so you can basically understand how it looks if we add the values. So we add values and we can see that these values are here. If we want to, just shortcuts, yeah, to put the value with the same key. So as you can see, we already have the value put it with the same key, and in this case you can see that we cannot that will not add us a new entry, but that will overwrite the existing one. However, so the keys are unique, yeah, as basically it stands for the name. All the key entry must, the key of the entry must be unique. For all the entries, if we use kind of different key, then the value can be repeated, yeah. So we can have the same value for different keys. That's the fine situation. But the keys must be unique, otherwise that will overwrite, that will change them, the value for them. And we have tree map as it stands from the scheme. That's the sorted map, yeah. So it is sorted by keys, yeah. We have the tree map that goes sorted automatically by keys. Okay. Yeah, it shows that it wants us to parameterize. So okay. But in this case, that's not really important because we do it on the right side. Okay, that's about the short introduction to the maps. And yeah, sorted set and sorted map are set and map which also allow sorting. Basically, they by default they are sorted, right? Yeah, but so it's not possible to place it in the position that will make this list, this collection not sorted, yeah. So it's practically not possible for the sorted list and sorted set and sorted map. And yeah, that's the schema, which excuse me, in internet you can, in Google you can find lots of such schemas. You're welcome to use them. Just basically I think that's the simple way to understand how this hierarchy is constructed. And yeah, here again we go from general to detailed. Okay, let's start with the maps. So as I said, it maps the keys to the values. So now we have the key and we have the value. Yeah, it cannot contain duplicate keys, as I already mentioned. The map interface includes includes methods for basic. Yeah, it's not really correct. Includes methods. Includes basic methods like put, if we want to put the new entry or change the value for the existing key. Get. Yeah, maybe let's just simply try them. If we want to get, then we need to provide the key. Yeah. So there are no indexes here. We simply need to know the key to get the corresponding the value for the corresponding key. Yeah. What else do we have here? Okay, maybe that's not really important for us. Compute contains replace size as usually, and yeah, basically remove and get are quite similar methods, because basically to remove something we need to find this something. Yeah. So in this case, just in general about the collections, about the tables. As I said it on Saturday, just small reminder to you is that basically if we have the command remove or delete from the table, don't forget that first of all we need to find this particular entry which needs to be deleted. And in this case it means that remove is read plus delete plus change the construction of the list after that. Yeah, and just a small visualization. So if we have the table with the entries, like we have the key, then we have some other values. So if we have the command read, it means that we need to search for the particular entry and get it, just read it from the table, and we don't change the table at all. If we have the command delete or remove, that's practically, first of all we need to read the entry, then we need to delete this entry after that. So we delete this entry, and we need to restructure, not restructure, but align the Alright, the sequence of the entries, because if we have, okay, maybe in this case that's fine if we have sorted one, but if we have kind of different, okay, since we have the sorted one, that's practically fine. We just need to maybe put these entries a little bit up in the table. Yeah, like if we have the table, just need to put the entries up. So delete also encodes the read operation, and also as we can see here, if we remove, it also asks us for the key to be provided. Okay, and yeah, as move contains key, contains value, size, and empty. So basically up contains key. In this case, we simply provide the key, and that will return us true or false. Sorry. If we have kind of the key which does not exist, here we simply get false. So basically this is needed if we just want to check if the entry exists. So use contains key. Or contains value also the option contains value. Contains value does. That should return true. If we contains comes, that will return false. So practically this is pretty straightforward also. There's the method empty. Yeah, that's snap is empty. Just in this case, we know that that's not empty. That's false. If we don't put everything, that should be true. Okay, then there are some bulk operations. It means put all or clear. So if we have multiple items to put all. Like imagine if we have another map, like let's add something to something more here. Then for the map we can put all, and we can add map 2. Then at the end we'll have the list combined, yeah, which remains sorted, so we just combine two lists. If we use the method put all, and maybe the trickiest point is if we have the same key, that basically means that will override, change the value from the initial list. Um, mm, no, not from the initial list. Yeah, from the initial list. Yeah, because we have. So we have the initial one. Then if we do it in opposite way, that that will use the value from the first list. Yeah. Now we can only one couple key value. No, we can have but yes and not. We can only have unique keys. We don't care about the value, so we need to have the unique keys. So we have the keys and we have the values. So we don't care about the values. We must have the unique key. So yeah, in theory that's correct. Then we cannot have the same couple key value because we cannot have duplicated keys. In this case, yeah, that's also results in the fact that we cannot have the same couple. But actually, it is more strict. We cannot have the same keys. Yeah, we can have only one variant of key. So we cannot have same keys. Yeah, we should have different keys. The keys must be unique. And that's why we can only have one couple. Yeah, that's correct. That's correct, but we can, yeah, in map we can have two columns, but we actually don't need more Svetlana. If we have the class, yeah, but if we have the class like table class test, for example, then we can add different attributes like we just let's not use encapsulation here. Value public integer, for example, value 1. Let's just use value 1. Have public string value 2. And then again public boolean value 3, and so on and so on. So if we create a new map table, then map table 3, yeah, we need to have map. Then here we provide the type of the key. Then we provide our test class hold test. Sorry, table class test. Then again we use new tree map, and yeah, I want to use these types again. So in this case, maybe let's add some entries here. Map table, but then you have the key. Let's use some kind of complicated key. Then here you can create new object, and yeah, maybe let's use the constructor here. Let's use the constructor here. Yeah, maybe. Yeah, let's use the constructor. So we have the value 1, string value 2, value 2, then boolean value 3. In theory, you can do it outside the constructor, just so in this case, let's just simply add the values on the constructor. So value2 equals value 2 from the constructor, then 3 equals value 3 from the constructor. And here we simply provide all these on these values. Okay, let's just simply use one as key. Then the value and value and the value. Just and here just simply can use the boolean, for example. Then we can put something else. And the second value is that false. So, and yeah, after that we can print it out, for example. And yeah, in this case you cannot really just, okay, maybe let's use iterator. Iterator equals map table iterator. Okay, I think there is no direct iterator. Yeah, I think that for maps there was no iterator, but just maybe once again redefine method to string and return value 1 equals just comma value 2 equals this value and value 3 equals this value 3. And let's return this guy. Okay. And yeah, now we can see that this is considered something like the table. Basically, the idea I wanted to show that in the value we can have more complicated structure than just a simple one field. Yeah, so as you said, there are only 2 columns. Yes, there are 2 columns, but in fact we can have more complicated objects, like the structure with different fields to be added here, and basically the same if we talk about the keys. However, there is one small problem. Okay, maybe let's finish with this one, and then we'll finish with theory today. Yeah, then we last thing today, from theory point of view, if we have a custom key class. So as I said, the same can be done for the keys as well. Like if we have public key 1, public string key 1, then public can be integer as well, key 2. Yeah, if we define okay, maybe let's just copy map table 2, then here we define custom key. And the same on the right side. In this case, that should be much more tricky. Okay, maybe yeah. So if we define key 1 equals new custom key, okay, I just don't want to yeah, that's key object might be because yeah, this looks not good. And that's the string. Okay, string 1 for example. So, and for the key 2, that's the integer. And yes. Yeah, that's just a simple example. We want key object 2, and we basically provide the same values here. So let's keep it as is for this one, and key object 1 and key object 2. And yeah, map table 2. And yeah, maybe let's override it for the key 1, this key 1. So I just basically want to do the correct output to string from this class, from the object of this class key 2. Yeah, just to have the correct display. And class cast exception. What's the problem here? Map table 2, custom key, new custom key. Cost, okay, there's 166. Where do we have the problem here? Custom key. It cannot be cast to class. Oh yeah, that's the implements comparable. Okay, yeah, maybe, yeah, that's what I wanted to show. Yeah, basically that's the problem I just in prior wanted to show it, because yeah, for values that's simple. We can simply use them. Let's just comment it out. To use them as the classes. To simply have like more fields inside the table. But for the keys, that's much trickier than for the values. Why? Because in the value we can basically store everything, and we don't really, and it is not everything which has the same type defined at the beginning. But for the keys, first of all, as I mentioned, the keys must be sorted. So we have the sorted map. In this case, we actually need to find a way how to sort them. That's the first, and the second one, we also need to, yeah, in this case, that only means that we need to compare one key to another. So if we have the objects on the website, it's not as easy as if we have the primitive data type like integer, which is already, yeah, basically we know how to compare them. For the objects, for the classes, that's a little bit trickier, because these are the objects and by default we have the reference. And if we have the reference as the keys, that's a little bit hard to imagine how we can use the reference as the keys. Yeah, if we kind of want to search, yeah, with theory we can imagine that we want to get the particular entry with the reference, but that's a more specific case, and how to deal with it we'll talk next lesson. So yeah, now let's move to the question part. Do you have any questions about it, about next home task, which is activity 08? Yeah, do you have any questions about them? And how to deal with this case, we'll talk about it on Friday. So how can we use the objects as the keys, and what should we do? Okay, I see Sandra. Okay, Sandra started. Yeah, okay, yeah, that's really good. Let's have 10 minutes break as usual. And, yeah, let's have the break now, because I think we haven't had the break for a long time now. Okay. Okay, I think you should be able to hear me now. Okay, let's move with this task. So practically, what do we have here? Okay, based on the questions from Sandra about the hint if informed and complicated statement informed and complicated things so if okay, yeah, basically what is meant here, that we have the if statement, and if the if statement is false, no, in this case we just want to, we assume that if statement is true, which basically means that we want to achieve that that's false, then we assert false. So basically using if statement, we simply have the statement here, which basically where we want to achieve the opposite one, and by using this we can simply assert that that's false, and then message the what's the issue. Okay, that was from Sandra. Validate the output and try. Okay. From Christina. Just a moment. Christina, validate output. Output. Yeah, that should throw the exception. Here we have done yes for try catch. That's that's pretty fine. Yeah, for Christine, basically yeah, what you do here, sorry, you throw the, so in this case that's that's it's a little bit interesting construction that you catch exception with the particular type, and then you throw this the same exception. That's I'm not sure how did you implement this divide operation, divide method here. Okay, but I think that's okay. I think that's also fine. I'm not really sure how did you implement it, these methods. But if you basically the idea is if you also throw the exceptions that you have simple calculation error there, that's fine as well. But in this case, it basically doesn't really matter which exception do we catch here, because basically if we point that this is the error, we can catch every exception, but I think that's also fine if you use this one. And this way, just let's see how you construct the whole program. Then we'll see if everything is correct there. But yeah, that's the pretty makes sense idea. Yeah, Christine, that's to Christine. One more thing. Let me check. Yeah, you have basically the try catch is created in a correct way. Yeah, let's see. Then yeah, let's see how you create all the other methods, and then let's see what's the result will be for this. Okay, and about the exception class, Christine, you have okay, that's ID, that's fine. Then you have two constructors. Yeah, that's fine. That's fine. But again, let's see how that will all in all look at the end. Yeah. Okay, for sweat one, have 10 failures, and the biggest question is about what to do. How to add additional exception for division by 0? Should it be some special constructor? Okay, let's see the last to do. Yeah, okay, this one. Division by 0 is perform. Yeah, okay, that should also throw the calculation exception. Sweat one. Actually not. You don't need to create any specific constructor for the exception class here. Just you just need to add this message to the constructor. So you have the simple try catch on the operation, and as you know, we should not have the problems with the plus, because basically we cannot have the problems with the plus. Then we cannot have the problems with subtraction, multiplication as well. We should not have the problems. The only problem is that we can have with division if we want to divide by 0. And basically in this case we can have only one exception. That exception is that division by 0 occurs. In this case we just simply need to throw the exception same way, just instead where we add the string, the message of the exception, you just need to add this text, yeah, division by 0. And that's it. Yeah, that's for Svetlana. Hope that's clear. Okay, any more questions? Okay, if there are no questions, yeah, just one information about the Friday session. Is it fine for you if we start at 6 and finish a little bit earlier on Friday? Okay, yeah, yeah, yes. Okay, then we no, I. uh, okay, maybe Svetlana, then we can we can start the session on Friday with the questions, and at the final part, Svetlana, you can at the end of the session, Svetlana, you can ask your questions. Yeah, maybe we can use the way that we start the session with the questions from other from other girls. Then at the end, Svetlana, you will be able to ask the questions as well. Right? Okay, and then yeah, I think that's and yeah, for those of you who won't be able to join at 6, then just yeah, we'll start with the questions from others, and then at the end you will also be able to ask the questions. Right? Okay, then thanks for your attention today, and let's okay, so then that's fine. Okay, then thanks for your attention today, and meet you on Friday.